Good afternoon. Welcome to today's lesson on section 8.5. So I didn't have a chance to make a worksheet. I've just been really just drowning in work here, so I'm just going to do this on Microsoft OneNote. Just write out the problems. Section 8.5 is about adding and subtracting rational expressions. And you might want to take notes on a notebook or somewhere else for the stuff. Okay. So this is a little different than what we did last time, because last time we did multiplying and dividing rational expressions. And those weren't too bad. It was just follow a lot of factoring, crossing stuff out. This is going to be a little bit trickier. Before we start, as a warm-up, here's what I'd like you guys to do. So I suggest you probably pause the video, try these 3 problems, and then play the video and see if you get the same thing. So I'm going to do this right now. So number 1 is easy. Changing colors, go to blue. Because the denominators are the same, you get 3/4. But here you need to find the LCD, least common denominator. In this case it's going to be 15. Because the least common multiple of 3 and 5 is 15. So coming back to number 2, we have 3/5 minus 2/3. Again, the least common denominator is 15. And the least common multiple of 3 and 5 is 15. So hopefully you guys remember this back from maybe 4th or 5th grade, whenever you guys did this kind of stuff. But you want to multiply top and bottom of the first fraction by 3 and top on the second fraction by 5. So you have 9/15 minus 10/15, which will be negative 1/15. And lastly, for number 3, a little weird. This we call a complex fraction, because you have a fraction within a fraction. And yeah, it does look kind of complicated, but it's a complex fraction. So in this case, we'll work that out. That will be, the LCD would be 6. So we get 3/6 plus 2/6, which is 5/6. And the bottom, whenever you have a whole number or an integer, always assume it's being divided by 1. So now I've got 5/6 divided by 2/1, which will be 5/6 times 1/2, which will be 5/12. So that's kind of a little warm-up. Now let's actually do the examples for today. So start with number 1. Let's say I want to do 7/4x plus 3/4x. So here we got ourselves 2 rational functions. Since the denominators are already the same, you just combine the numerators. And you can actually reduce this if we wanted to. So we have 5/2x. Let's try another one. Number 2. 2x over x plus 6 minus 5 over x plus 6. Notice the denominators again are still the same. So we can combine it by subtracting 2x with 5. And that's the best we can do. So there's really not going to be any factoring you're doing here. You're just going to be combining 2 fractions. Okay, now let me step this up. 7/9x squared plus x over 3x squared plus 3x. Now in this case, if you want to find the LCD, this is a little tricky. Probably helps to factor each denominator first. So this becomes 3x, x plus 3. And of course 9x squared is just 9x squared. So what is the LCD for 9x squared and 3x times x plus 3? That's a little bit tricky. But here's what you can do. 9x squared we already know is 3x times 3x. So all it's missing, because it already has the 3x built into it, all it's missing is just x plus 3. Here, let's go back to blue. You have 3x times x plus 3. We need another 3x. So now these are identical. So I'm going to multiply this by x plus 3 and multiply this by 3x. So now I've got myself the following. 7 times x plus 3 plus 3x squared over, and we can write this as 9x squared times x plus 3. Clean it up. 3x squared plus 7x plus 21. If you distribute the 7 into x plus 3. And down below we have this. No need to really distribute. You can leave it like that. And that'll be our final answer. So it's very important you gotta find the LCD. Let's try another one so you guys can kind of get the hang of this. Number 4. How about x plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. This, by the way, is example 4 on page 584. So you need to find LCD first. So we know this is 2x minus 1. And we know this, if you factor it, x minus 1, x minus 3. So clearly, this needs an x minus 3, and that needs a 2. So I multiply top and bottom of this by 2, top and bottom of this by x minus 3. So we work it out, you get x minus 3 times x plus 2 minus 2 times negative 2x minus 1 all over our LCD, which is 2x minus 1, x minus 3. Notice how I don't write it like x squared minus 4x plus 3 anymore. Clean it up. X squared, negative x minus 6. And then be careful, you have negative 4x minus 2. When you distribute, you have x squared minus x minus 6 plus 4x plus 2. So you have x squared plus 3x minus 4 over 2x minus 1 times x minus 3. And actually this can be factored. So if there's a potential to factor, that's kind of confusing. Let's just go down here. If there's potential to factor, you have x plus 4, x minus 1, 2, x minus 1, x minus 3. Cancel, cancel. So it's x plus 4 over 2x minus 3. So just a lot of algebra you're doing here. Okay, last example, number 5. Let's look at a complex fraction. Great way to end off the lesson for today. So what you want to do is combine these two first, so that way we'll just have a fraction divided by a fraction. It'll make the problem easier. So if you combine those two first, you have 1 over x plus 4 plus 2 over x. LCD will just be x times x plus 4. So you're not going to have anything, it's not like you can factor out x from x plus 4, so you just have to multiply those two together. So when we work that out, we have x plus 2x plus 8 over x times x plus 4, which is 3x plus 8. So now we bring it back in. So we cleaned up the bottom part. Now flip over the bottom fraction. And now it becomes kind of like the problems we did during block 1 of this week. Gone, gone. And so final answer is just 5x over 3x plus 8. And the reason why we're doing this stuff is we're going to start solving equations next week. And so the video of the weekend will be on solving rational equations. But we need to make sure you guys can multiply, divide these rational expressions, add and subtract them. So I'm all done. Ben, do you want to say what's up? Do you want to say hello?
Have fun watching the video.
Alright, so Ben Ferkel says what's up. Alright, anyway. And no, he's not in my house, he's in my classroom. So don't get any weird ideas. So I'll see you guys on Friday. And also, actually I'll put my Super Bowl prediction on the video next time. So I was going to put my Super Bowl prediction, but I'll hold you guys in suspense for another day or two. Alright, goodbye.